So we're working on the system x plus y equals negative 11, x minus 3 squared plus y plus 6 squared equals 34. Priscilla, I will not forget to show those two. I promise. Even if they suggest all other problems, I'll sit down with you and we'll work on these two. Promise. Promise. Okay, very good. Ready? Now, since the variables are not the same, my only chance is substitution. It doesn't matter if you solve this equation for x or for y. Both have leading coefficient 1. It doesn't matter. You tell me which one would you like to solve for. It does not matter.
The less threatening, which is the first one.
But the question was which variable. Of course we have to solve. That's fine. If we want to solve for x, that's great. So then we will replace x in the second equation by negative y minus 11. Negative y minus 11 minus 3 squared plus y plus 6 squared equals 34. Are we okay so far?
Yeah.
Yes? Great. Now remember, when we simplify this and combine like terms, if both terms are positive or both terms are negative, when we square, everything gets to be positive. If only one of them is positive and one is negative, then there is a middle term that is negative. But if both are positive or both are negative, everything will be positive. I can show separately why. So when I factor out negative 1 here, I get this. But when I square negative 1, I get positive. And square y plus 14, I still get y plus 14 squared. So if both terms are negative or both terms are positive, the answer will be all terms positive for this reason. Okay? So now when I square y plus 14, or negative y minus 14 is the same thing, how many terms do I get?
3.
Awesome. First day of classes. Excellent. First term squared plus 2 times the first times the second plus 14 squared, whatever that is, plus, can anyone give us the second? I'm sorry, this is my cell phone. I'm sorry. My apologies. Okay, y plus 6 squared. 3 more terms. First term squared plus 2 times the first times the second plus 36 minus 34 equals 0. So one more time, let's do this together. When I square y plus 14, I get 3 terms. The first term squared plus 2 times the first times the second plus the second term squared, which I'll figure out in a minute, plus the first term squared plus 2 times the first times the second plus the second term squared. I subtract 34 and set it equal to 0. So far, so good? So then, y squared plus y squared is 2y squared. 28 plus 12 is 40y plus, this is 196, and this is 2. So plus 198 equals 0. Quadratic equation, how many solutions do I expect? How many?
3.
2.
2, because the degree is 2. We expect 2. Of course, I will clean it up, dividing both sides by 2. So I have y squared plus 20y equals 9, plus, of course, equals 9 plus 99 equals 0. If it takes, remember, 30 seconds to factor, then factor. If not, forget it. And use what? X equals negative b plus or minus b squared minus 4ac over 2a. With the graphing calculator, be careful how you put it in. Parentheses around the numerator. So in parentheses, negative 20 plus the square root. I always put parentheses under the square root. 400 minus 4 times 99. Close the parenthesis, go outside of the square root, close the parenthesis and divide by 2 and press enter. And I get negative 9. So x equals negative 9. But I expect another solution with a negative in front of the square root. So I go back. Minus, enter, negative 11. So x equals negative 9 and x equals negative 11. Then what? Is this good enough? No, it's not good enough because we need to plug it in and determine y. Excellent. So remember y was, I'm so sorry. This is actually y, sorry. So x was negative y minus 11. So how much is x when y is negative 9? Negative 9 with minus in front is 9. 9 minus 11 is negative 2. So y negative 9. So negative 2, negative 9. Can anyone give us the other x? So we have negative 11. So positive 11, so that will be 0. When y equals negative 11, so 0, negative 11. And you can always go back and what? Always go back and plug it in and check, of course. And I would always do it. I would always do it. Is this okay?
I think we did like the same problem, number 16, in my class, and we did it differently. But
Yeah, because we solve for y instead of for x.
Okay.
Same thing.
Okay.
I always ask my students what they want, and I do what they want. So, yeah. So in the previous class, my students, if you remember, they said, I want to solve for y. So we solve for y, and we plugged the y in here.
Okay.
So we solve for x first, but the solution must be the same. We still got negative 2 comma negative 9 and 0, negative 11. Mandatory. There's nothing else. Yeah. I just always like my students to do what my students want.
I was just looking at my notes and I was like,
That's okay. Yes, yes. Don't forget to fill out the survey, please. I know it's another survey, but it will make me very happy if I normally get 80 to 90% response rate, so if you could, and I give extra credit for that.
So what's the last then grade?
It's next week, so they will close the survey.
I mean,
Options.
but the extra credit is towards your end grade.
To tell your final exam grade. Very good. I think you said also 17?
Yeah.
Okay, very good. So let's look at 17. So let's see. At 17 we have y greater than or equal to x squared minus 49 and x minus y greater or equal to negative 7. This is a system of nonlinear inequalities. Our only chance is by graphing. So we have to graph the equation first. So y equals x squared minus 49. We graph this way too many times. How do I graph it?
It's a quadratic, so it's a, what's it called?
X squared. And then down how many?
49.
Right. So agree, I hope, with me. Okay, let's say this is negative 49. So 0, comma, negative 49. Where does it cross the x-axis, though? 0 equals x squared minus 49. Now we know x must be, or, yes, plus or minus 7. So let's see, say negative 7 and 7. So this is it a solid curve? It is a solid curve because of the equal symbol, yes. So here we only graphed x squared minus 49 equals y, or y equals x squared minus 49. Now we're trying to solve this inequality by plugging in 0, 0, because I am interested in the origin, because I'm lazy. So 0, 0, 0 greater than or equal to negative 49. If you say yes, I'll shade in the inside. If you say no, I will have to shade in the outside. Will you say yes or will you say no? You will say yes, indeed. So this inside, including points on the curve, y greater than or equal to x squared minus 49. I have to repeat for x minus y equals negative 7. And x minus y equals negative 7 when x is 0. Cover it and tell me why. Very good. So 0, 7. And now when y is 0, cover y. So x equals, excellent, negative 7, 0. So negative 7, 0, and 0, 7. Solid curve? Line, in other words? Yes, solid. This is just the equation of x minus y equals negative 7. It divides the plane into two regions. I want to check 0, 0. 0, 0. Is 0 greater or equal to negative 7? If you say yes, I'll shade in the bottom. If you say no, I have to shade in the top. You will say yes. So then I'm shading in all the bottom. And this is x minus y greater than or equal to negative 7. Now, if purple and blue, and green overlap, then the system has solutions. If they don't overlap, the system has no solutions. What would you say? The system has solutions or does not? Yes, of course. Everything on this, everything on this, and everything in between. And this is both. Or when I say both, I mean the entire system. Very good. Anything else from N4 test 3 on Monday? Is there anything, any topic that you say, I need to see another one? Just browse through.
Maybe the
Yes?
the last one.
The last one?
Jordan stuff.
The Gauss-Jordan?
Mm-hmm.
Yes. You want to choose another one? Is that what we want?
Yeah.
Okay. So these problems are in 6.1. So let's go to 6.1 and choose another. Or we can choose from the end of the chapter, chapter 6. Do you trust me to choose one? Or
I trust you.
Thank you. 6.1. Okay, I have, you choose if you'd like. On page 687, I see two problems there. Problem 3 and problem 4. You choose which ones. They are the same to me. They look the same. Page 687, 3 or 4. Okay, we picked 4. And 4 is x minus 2y plus z equals 0. And y minus 3z equals -1, and 2y plus 5z equals -2. Very good. So we want to solve the system using Gauss-Jordan. Perfect. So now I'm going to write the augmented matrix. 1, -2, 1, 0, 0, 1, -3, -1, 0, 2, 5, -2.
That's advantageous.
Very advantageous. This is already done, and this is already done. Very convenient. Thank you. Thank you, Priscilla. You made it easy on us. We love you. Good. So then I'm going to multiply which row?
Row 1.
Oh, it's all done.
Oh, I lied.
Row 2. Oh, I'm sorry. Row 2 by, and you'll tell me, and then row 1. And row 2 by, and add it to row 3. What do I multiply row 2 by to eliminate -2? Okay, thank you. What do I multiply row 2 by to eliminate 2? Good.
Why
Sorry.
did I choose row 2?
Because I have the 1, and I need to eliminate this, and I need to eliminate this.
Okay, because the first column.
It's already done.
Done.
Thank you. You're very good to us. So then 1, 0, 0. I copy 1, -3, -1. Together, 1 times 2 minus 2.
0.
-3 times 2 plus 1.
-5.
Good. -1 times 2
-2.
plus 0.
-2.
Excellent. 1 times -2 plus 2.
0.
-3 times -2
-6. Sorry, +6.
plus 5. Excellent. -2 times, I'm sorry, -1 times -2,
2.
and 2 minus 2. Nice. So now this is done. Where am I and what am I doing? Sissy, please. Please. So then, so we have R3 divided by 11. Very good. So then we have 1, 0, -5, -2, 0, 1, -3, -1, 0, 0.
1.
0.
Exactly, because 0 divided by 11 is
0.
excellent. Great job. Good. So now,
Can I count them?
say it again.
I'm finishing writing.
Sure. Better? Is that you have enough?
Yeah.
Okay. So now we want these. Which row do I have to use?
3rd.
Right. I have no choice. Row 3 plus row 1, row 3 plus row 2. What do I need to multiply row 3 by to eliminate the -5?
5.
Perfect. What do I need to multiply it to eliminate the -3?
3.
Very good. So then I copy 1, 0, 0, 1, 0, 0, 1, 0. And I'm ready when you are. One times 5 minus 5. 0 times 5 minus 2. 1 times 3 minus 3.
0.
0 times 3 minus 1. What do you expect? I don't know,
-2.
but I expect this. Would you agree? Do we know for sure? No. We plug it in. -2, -1, 0. Okay. -2, but +2 and +0. Check. -1, but -0. Check. -2, but plus 0, check. So, yes. Good. Anything else? Is there anything else that you would like to go back to, review? Are we ready for this test on Monday? Yes, please, Sissy. Number 10. From this? Number 10. Okay. And number 10, we have 9 raised to x plus 6 equals 81 to x minus 8. Any suggestions?
You base the 9 and 8.
Exactly. So this is 9 raised to x plus 6. We normally like prime numbers, but in this case, this works.
So I want the base to be the same number.
If it's possible. If it's not possible, then I apply log.
Okay.
And I'm done. Right? But if in this case it's possible. If it is possible, normally it's much easier than applying log. So in this case, I have 9 raised to x plus 6. And what do I have on the right-hand side? I have 9 raised to... Exactly. So now two numbers are equal and they have the same base. Do not try to simplify the 9s. We're not simplifying. We're not dividing. We're just thinking. If two numbers are equal and they have the same base, what must happen for sure?
Both the sides.
Indeed. I move 2x becomes negative. I move 6, negative 22, x equals 22. Any questions? Any other type of problem that you would say, I need to see more? Or you will not say, but you just pick a problem. Which one?
If you haven't already.
That's okay. Number 8, and which one, Michelle?
Just another practice one for the summation.
For the summation notation. Very good. So let's look at number 8. In number 8, we're asked to expand. So we have log base 4 of the 7th root of a to the 6th b minus 1 to the 3rd over 16. And remember, the 7th root is which power? Because that power has to go in front as a factor.
1/7.
Very good, awesome. So this becomes 1 over 7 log base 4 of a to the 6th b minus 1 to the 3rd divided by 16. And last time we talked about it. It's okay if you write everything under, but it's more hurting to the eye, right? It's a big fraction with a denominator. So what I recommend is put 1 over 7 in front and make it weight. So quantities that come from the top will have plus in front. Quantity that comes from the denominator will have negative in front. So this is log base 4 of a to the 6th plus log base 4 of b minus 1 to the 3rd, but minus log base 4 of 16. That's why I emphasize that from the very beginning, because it makes it a little bit easier. Because this problem, you can write like the whole page on it. But if you just think in terms of if it's a quantity, a factor, not a sum or difference, but if it's a factor coming from the top, we will have plus in front of the log. If it's a quantity or a factor coming from the denominator, it will be negative in front. So then all I have to do is bring the 6 in front, bring the 3 in front, and change this. What do I change it into? Log base 4 of 16 is whatever. 4 raised to what is 16? 2. So this gets changed into 2. So then I have 1 over 7, 6 log base 4 of a plus 3 log base 4 of b minus 1 and minus 2. At this point, I remove brackets by distributing 1 over 7 to all terms. So 6 over 7 log base 4 of A, 3 over 7 log base 4 of B minus 1 minus 2 over 7. Priscilla, is this one clear? The one that we talked about, the 2 in front?
Yeah.
Okay. Great job. Next question, anything else that you would like to go back to?
The summation.
Yes, of course, of course, of course. So, any preference?
No preference.
So, do you want something with the expressing this? Do you want something? So, yeah, I guess that's what you wanted, basically. Okay, so let's look at this is from section 8.1. So let's take a look. 8.1, 8.1. If you like to choose, if not, I will.
And I don't have those.
That's okay. So you want to be given the summation and find the terms and the sum, or you want to be given the sum, the terms, and find the sum?
Probably the terms.
So you are given the terms and you want to find the sum. Okay, perfect. So let's take a look at an example like that. On page 753, let's say, I don't know if we did this problem or not, 4 plus 4 squared over 2 plus 4 cubed over 3 plus dot 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 plus 4 to the n over n. We're asked to write the summation notation. This is 51 on page 753. And then we can look at one backwards. So, of course, I will imagine that there is a 1 and a 4. So I see 1, 2, 3, blah, 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 n. So obviously I'll say, let's say j starts at and ends definitely with
N.
Good. I see that all of them are fractions. What do you have at the top? There is no n. J over j. And now let's take a moment and find those terms. When j is 1, 4 to the first power over 1. Check. When j is 2, 2 over 4 squared over 2. Check. When j is 3, 4 to the third over 3. Check. When j is n, 4 to the nth over n.
I think I just have to read it like that, because I would put the N next to
No,
that
you
four.
cannot, because this is the j that goes from 1 through n. So here you can only have j. If you have I, only I. If you have k, only k.
So that bottom number should only, or the letter should be only, for the most part.
It could be at 2, it could be at 3, but most probably starts at 1.
Okay.
Can you explain one more time? Just
Which part?
the entire thing.
So I just see a pattern, 1, 2, 3, n. So then this must be j from 1 to n. Then I see another pattern, 4 to the first, 4 to the second, 4 to the third, 4 to the n, n and n. So this must be j and j. And all the bases are 4. So this is this. Let's see how we get those terms. When j is 1, I get this first term. When j is 2, I get this second term. When j is 3, I get this one. And finally, when j is n, I get this one.
And how do we get in at the top again? Because that's the
You mean the upper limit?
yeah.
Because it ends at n. If this were 9, I would have ended with 9. Is that better?
So is that from concept?
It's 51 on 753.
But not on the paper, right? Not on
No, it was just a practice.
the, oh, okay.
Now here's another. Let's take a look at, let's say, 33 on page 752. Now we're given k equals 1 through 5 from k and k plus 4. Let's say we are asked to find the sum. How do I determine this sum? First of all, how many terms will I find? Indeed, for k equals 1, 2, 3, 4, and 5. Excellent. Can anyone give us the first term? Don't calculate anything, just tell me the term so everyone can see it. Yes? Very good. Can anyone give us a second term?
2 parentheses.
Very good. Can anyone give us a third term? Very good. Very good. Of course, 4, 4 plus 4, and the last one, 5, 5 plus 4. I have two options. I can determine this by hand or also put in the graphing calculator. Why don't we do both? Ready? So let's do it by hand first, and then see what we get with the graphing calculator. So obviously this is 5 times 1, so this is 5, plus this is 6 times 2, plus this is 7 times 3, plus 4 times 8, and 9 times 5. Do we agree so far? Okay, so let's add these. So let's say I like to add them in twos. You do whatever you want. So let's say this is 33, so this is 38, and this is 77. So 5 and 1, I got 115. Ready? So some calculators have this feature in math and in zero. Now, if your calculator for the test or the final does not have this feature, feel free to use the software.
And where did you?
So you can, zero. Math and
Oh,
zero.
zero.
You may not have it. So if you don't have it, you can come and calculate here on the computer. I don't have any problem with that. Okay? So if your calculator doesn't have it. So in this case, we have from x goes from 1, and you said 5. Excellent. And in parentheses, I have x, and in parentheses, x plus 4. And close the parenthesis. And when I hit enter, if my calculations by hand are correct, what should I get?
115.
Okay, let's see if it's 115. It is. Michelle, is this good enough? Is that what you had in mind?
Yes.
Okay, is there anything else that you would like to go back to, any type of problem? Exponential equations, log equations, anything?
Number
Any?
6.
Say it again.
Number 6.
Number 6.
Transformation.
Very good. So let's look at number 6. So this was 7, and now 8. And we have g of x equals log x minus 3 minus 1. So with this problem, we are asked to use transformations. Sorry. With this problem, we're asked to use transformations and present the graph in the order of operations. And also, we are asked to find the x and y-intercepts algebraically. Good. We have to start by finding the domain. and then the base function, and then step by step, build this function. Ready? Good. So how do I find the domain of a log function? What do I have to write? I have to write that, or we always do that with log equations. So I know how to find the domain of this function. Go back to log equations and say, I know you have to write blah, 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 blah. And I will write it.
What number is this?
6. Thank you.
Thank you. Oh, you said what's in parentheses equals 0. I mean, no. Less greater than 0?
Greater than 0. Always greater than 0. So x minus 3 greater than 0, x greater than 3, domain 3 to infinity.
And that's for whenever you're finding
For
out
any log.
for any log.
Absolutely any log,
You have
the
to
quantity we apply log to must be strictly positive. The same thing with the square root. X minus 1, however, must be greater than or equal to 0. So always keep these two functions in mind kind of together, because both of them cannot be applied to negative numbers. One of them can be applied to 0, though. The other one cannot be applied to 0. So this has to be strict inequality. This one can be equal 0.
And if it was the greater, the greater than or equal to, would you have the little, you wouldn't use parentheses,
But a bracket.
brackets?
Yes, but not for this. Not for this, because log cannot be applied to 0. In case you forget, plug in this function 3, and you'll see it's undefined or error. So you can do that. So in y equals, if you want to put log, in parentheses x minus 3, close the parenthesis, and you go to second and table, and I want to plug in 3. The calculator will, second and table, sorry. The calculator will scream at me because it's a vertical asymptote. Okay? So, knowing that, now let's identify the base function. And you will say the base function here is
x equals x.
look at this function and say, oh, this function was used to create this one. It's right there. Which function did we use to create this one?
X minus 3.
No. Yes? You said it?
I did.
No, Rachel did.
I did?
Yes.
X minus 3. Minus 4.
You started something else afterwards.
Oh, I said that.
Yes.
Um,
Indeed. Log x is the function that is used here. Absolutely. And the first transformation on log x is?
Was it to the right?
I have to write it first. You're right. Exactly. I know the domain. It has to be to the right. But I have to write the function. Is log x minus 3, right 3. Excellent. Number 2.
Log x minus 3 minus 1.
Very good. Exactly. Down 1. Excellent. But now I have to remember how to graph this function. Because log and exponential have two shapes. One shape is when the exponential is increasing or the exponential is decreasing. The other shape for the log is increasing with base greater than 1 or decreasing with base less than 1. So which one is it? Increasing. Very good. So this is log x with a vertical asymptote at x equals 0. Now you told me to shift this graph 3 to the right. Remember, this point is 1. But I have to shift the vertical asymptote first. Where do I shift the vertical asymptote to? Exactly. 1, 2, 3. I knew it from here already. It must be x equals 3. So now log x moves where? So this point, my reference point, will go 1, 2, 3. Where does it go? 2. What point is this? Very good. Indeed. So this is log x minus 3. Great job. And now, exactly, where does this point go? That's my marker. That's my reference point right here. So this is the final graph. This is final. Log x minus 3 minus 1. Can anyone give us the domain of this function? Yes, it's 3 to infinity. Can anyone give us the range of this function? To positive infinity. Very good. Final question, the x and y intercepts. How do I get the x-intercept? And let me ask you this. Does this function have a y-intercept?
Yeah.
No, absolutely not. Not a y-intercept. Why? Because I can't plug a 0 in it. The domain is 3 to infinity. How can I plug in 0 in it? I won't be able to. But how do I find the x-intercept? Exactly. So then I have log x minus 3 minus 1 equals 0. How do I solve this equation, and what type of equation is it? Of course, it has log in it. It must be a log. What do I have to do first? But I have to move 1 first. Clean it up. Log x minus 3 equals 1. And then I will write the exponential equation starting from the base, counterclockwise, raising to this power. I don't see the base. Indeed. 10 to the first power. Please do not multiply. It's not 10 times 1. Is this raised to this power equals x minus 3. So 10 equals x minus 3, so x equals 13. Does this make sense? Yes. So then my graph is good, but not good enough. So it should go way out there here. The x-intercept is at 13, 0. Yes?
How did you know that there wasn't a y-intercept?
Because the y-intercept is determined when x is 0. Can I plug in 0 in this function? No. First of all, it has a vertical asymptote. There is no way this graph will touch the y-axis.
Okay.
Better?
Mhm.
Perfect. Very good questions.